Cooking an Egg by Kit Braddock,
Raven Jones,
Carmen Artola,
Cal Damachafi.
Chemistry behind cooking eggs. There are many physical and chemical changes that occur in the everyday process of cooking eggs. Lighting the stove results in a chemical change, but the gas turning to fire while the skillet heating up does nothing but change physically. The most important chemical change in this process is that of the egg, turning from a raw egg white and yolk to fried or scrambled egg. The following slide shows a video of the physical and chemical changes described in more depth.
This is a video of physical and chemical changes of cooking eggs.
It's 10 o'clock on Saturday morning. It means only one thing. It's time for breakfast. As the gas flows through the burner, it is invisible and has a distinct smell. It stinks! When we light the gas, it becomes visible, gives off light, produces lots of heat, and the smell goes away. So long, stink town! Burning the natural gas also produces new gases, including carbon monoxide, water vapor, and hydrogen. It also requires oxygen in order to burn. The products of this reaction also include heat and light. Burning the natural gas is an example of a chemical change. Methane comes in, but it doesn't leave as methane. It leaves as a bunch of other gases. But it's breakfast time, and I'm more interested in eating than I am talking about this chemistry.
I need my sprints.
When we put the frying pan on the burner, the metal starts out pretty cold. We need to wait for a few minutes for the pan to warm up. The pan is much hotter now than it was before. The pan's change in temperature is an example of a physical change. The pan is warmer and slightly larger because metal expands when it gets hot, but it's still just a pan. When the egg hits the pan, it immediately starts to sizzle and pop. The egg white turns from clear to white, which makes sense given the name. It also starts to smell much better. When heat is added to the raw egg and liquid water inside the egg, the heat causes the water to evaporate into water vapor. The proteins in the egg also realign to form a whole new substance, cooked egg. The wonderful smell is another product of this reaction. This is another example of a chemical change. But by far, my favorite part of this chemical reaction is the way it tastes delicious. As where before, it tasted not delicious. And where exactly do these eggs come from? That'll just have to be a lesson for another day.
The science of eggs. Egg proteins change when you heat them, beat them, or mix them with other ingredients. Understanding these changes can help you understand the roles that eggs play in cooking. Proteins are made of long chains of amino acids. The proteins found in an egg white are globular proteins.
heat them. In the illustration to the right, you can see egg being heated. Applying heat causes the molecules of the egg proteins to bounce around and interact with surrounding water molecules, forming new chemical bonds. After bouncing around long enough, the egg proteins are no longer solitary. The water in which the eggs once floated in was captured and contained in the protein web. Cooking too long could lead to a rubbery texture. Beat them. Beating eggs causes air molecules, which in turn causes the globular proteins to unfold. Egg white proteins contain both hydrophilic and hydrophobic amino acids. When the egg is whole, the hydrophilic parts are on the outside closer to the water. Hydrophobic are packed in center. When egg proteins are up against an air molecule, water-loving parts are immersed in water, while water-fearing sticks up in air. Once the eggs have been beaten, the proteins unfold, creating a network, keeping the air molecules in place. When you heat the eggs, the air molecules expand as a gas and burst, but does not disturb the structure of the eggs.
Mix them up. Egg yolks have many emulsifiers. Emulsion is defined as a fine dispersion of minute droplets of one liquid and another which is not miscible. Using an emulsifier like eggs will prevent the two from becoming colorants. Mixing eggs and oil and water will cause one part of the egg to mix with oil and the other to mix with the water. The chitin is an important part. It's a fat-like molecule with a water-loving head and a long water-bearing tail. The tail gets buried in the fat droplets and its head sticks out of the droplet surface into the surrounding water. This establishes a barrier that prevents the surface of the fat droplet from coming into contact with the surface of another fat droplet.
Our sources for this project were from the Exploratorium website for the science of our eggs. We got our video from YouTube, and all of our images were from Google.
Thank you very much for watching.